Hi, this is A. Vijayalakshmi, working as an assistant professor at VIT University, Chennai. In this video lecture, I would like to discuss the challenges and issues in various types of data mining. First, we will see what is data mining. Extracting or discovering the knowledge from large amount of data is called as data mining. As well as we can process and analyze the data from different perspectives, and also we can summarize the result into useful information, and we can find correlations or patterns among huge amount of data. In our previous definition, we use the word data, information and knowledge. First we will see what is data. Is nothing but a raw fact. Information. The processed data is called as an information. Knowledge. Information converted to knowledge to find useful patterns and future trends. Next we will see what is data warehouse. It's nothing but a central repository of information which are collected from the multiple sources and it's stored in a single unified schema. It's called as a data warehouse. Next we will see what is the need for data mining. By using data mining, we can analyze the relationship and patterns in the data based on the end user request. For analysis, we can use statistics, machine learning and neural networks techniques. We can do 4 relationships using data mining. First one is classes, which is used to locate the target. Second one is cluster, which will group the data items. The third one is association. We can find out the relationship among the data. And the fourth one is sequential pattern, which is used to find out the behavioral patterns and trends. These are all the 5 elements of data mining. The first one is extraction. From multiple sources, the data which are collected, transformed and loaded into the data warehouse. Second one is storage and manage. Third one is we have to provide the data access. The fourth one is we have to analyze and process the data. The fifth one is the result should be presented to the user as an output. Next is KDD process, that is knowledge discovery in database. KDD is a interactive and iterative process. It is a core process of data mining. It consists of 5 steps. The first one is selection. From multiple sources, the data has to be selected. Second one is pre-processing. Third one is transformation. The fourth one is applying the data mining techniques to extract the knowledge or patterns. The fifth one is the result has to be evaluated and the accuracy has to be fine. These are all the tasks of data mining. The first one is classification. Second one is regression analysis. And the third one is change detection. And the fourth one is clustering. And fifth is dependency modeling. And the last is summarizing the result. These are all the tasks of data mining. Next we will see the issues in the modeling of data by using data mining. First one is data preparation. From multiple sources, the data has to be collected and it has to be stored. Second one is unknown target. Always the target will be unknown. Third one is oversampling. Fourth one is under coverage. The next one is dirty data. that is unwanted data will be in data collection. Next is errors. Inconsistent data will be available. Next one is missing values, that is incomplete data. Dimension reduction. Because we are extracting the knowledge from the multidimensional data, we cannot able to use all the dimension, so we have to apply some of the techniques to reduce the dimension. Next one is under and overfitting. Next, temporal infidelity, and finally the result has to be evaluated. These are the issues and difficulties in data mining while we are doing the modeling. Next we'll see the types of data mining. The types are multimedia data mining, image mining, video mining, audio mining, text mining, and web mining. Now we'll see the challenges and issues in various types of data mining. First one is multimedia data. What is called as multimedia data? Audio, video, image, and text data is called as multimedia data. What is multimedia data mining? Exploration and analysis of video, audio, image, and text data to find out or to discover meaningful patterns and rules is called as multimedia data mining. These all the steps are there to extract the knowledge from the multimedia data. First, as an input, you have to consider audio, video, image, or text data. Second step, we have to do the pre-processing. Next, we have to extract the features and we have to do the transformation. And the third step, we can apply any one of the mining technique to discover the knowledge from the multimedia data like classification, clustering, association, etc. Finally, from the result, we have to interpret the knowledge, or we have to prepare the report which will present the knowledge to the user. It is called as a post-processing, and finally the result has to be evaluated to find out the accuracy. Next we'll see that what are the types of data available in the multimedia data mining. We can use digital data, web data, as well as medical data. Digital data, that is digital media data. It may be a still image, or it may be a MP3 songs, or it may be a video file, or it may be a cell phone or video camera data. Next one is web data. Web content data, that is multimedia document in the web, or we can use any of the web structure data, that is inter-document link. We can use any of the web usage data that is generated by the user through the interactions in the web. In the multimedia data, we can consider the medical data also, both in image and numeric format. Numeric format means like laboratory reports, and image format like CT scan and MRI scan. These are all the data which are considered under multimedia data. Next we'll see the multimedia data mining problems and approaches. First, the multimedia data has to be pre-processed and features has to be extracted, transformed, and it should be represented. We can do the feature extraction different levels, or we can do the feature fusion, or we can do the feature synchronization, as well as we can find out the correlation and accuracy. For doing this, we can apply any one of the statistical data mining techniques like association, classification, clustering, and visualization. In multimedia data types, there are a lot of current approaches available and lot of limitations also is there. All the problems are open problems. That's why multimedia data mining as an attracted significant research, and we can develop many tools and methods in the multimedia data mining. We can do organize, manage, search and perform lot of domain specific tasks such as surveillance, meetings, broadcast news, sports, archives, movies, medical data, as well as we can do any personal and online media collections. Next we will go for the image mining. The first task we have to do in the image mining is pre-processing. We can do the pre-processing in the pixel level or region level or grid level. The issues are we can extract the features in global level or in the local level. Next task is feature extraction and transformation. We can use the color histogram technique or color movements or color sets, shape descriptors, texture descriptors and edge detection method. Issues. These methods are sensitive to the parameters like number of bins in color histogram, finding the bin boundaries, selection of feature vectors. These are all the issues. We can apply the task to do the classification of the image. The approaches we can use is GMM method, support vector machine method, Bayesian classifier to classify the image. These are all the approaches we can use to classify the images and issues. Large training data is needed for GMM as well as SVM methods. Next task we can do the clustering of the images also. The approaches we can use is K-means. We can identify the patterns by using the K-means. The issues in K-means is the number of clusters are unknown. Next we can able to use association rule mining to find out the relationship in the images. For that we can use the approach a priori based association rule mining to find out the frequent images, as well as we can apply any one of the human brain functions like neural network based rules. And the issues, scalability is a big issue in the image association. Image mining trends. We can extract the feature in the low level, that is we can do the color histogram, texture analysis. These all the things are called as low level feature extraction. Next, intermediate feature representation, that is visual code book. Next, high level feature representation. We can identify the object, concept and event. Next, we can use small scale data set or large scale data set. Small scale data set like CT scan data, personal photos, etc. Large scale data set we can use any photo signing. Next we will discuss about the video mining. The first task is pre-processing. We can apply the approaches like in shoot level, frame level, scene level, as well as in the clip level. Issues. All this level depends on video structure and application type. Next, feature extraction and transformation. Image features at frame level as well as motion level. We can apply the approach in the camera metadata like camera motion, date, place, time, etc. The issues are motion calculation will be computationally expensive. Next task, we can classify the video. The approach we can apply is human body motion recognition, goal detection, gestures, etc. The issue is not enough training data is available. and it is depends on domain knowledge. Next task, video clustering. We can cluster or shoots segments of video, or we can do the indexing. These are all the approaches we can apply. Issues. Scalability of large video cluster is an issue. Next, video association. We can find out the association among the video using a priori based association rule mining to find the sequence of events in movies. Issues. Finding the semantic event and boundaries and finding the temporal distance is a big issue. Next, video mining trends. We can apply the video mining in here, intra-video mining as well as inter-video mining. Intra-video mining, that is clustering of news, videos, weathers, interviews, stock exchange, etc. Inter-video mining, we can clustering of the YouTube video clips. Next one is we can apply the video mining in the content level as well as in the concept level. Content level, we can find out the duplicate video as well as in the concept level we can find out not duplicate but similar concept. Next we'll go for the audio mining. The first task is pre-processing. We can apply the approach in the phoneme level, word level, or in the window of pixel size. Issues. All these levels are domain dependence. Next one is feature extraction and transformation. The approach we can use in the feature extraction is pass rate, zero crossing rate, MELF frequency, cepstral coefficient, or we can use the bandwidth, spectral, centroid, frequency spectrum. These are all the approaches we can use for the feature extraction and issues. It is highly sensitive to the parameters and smoothing factors is a big issue. Next one is classification of the audio files. We can apply HMM method, GMM, SVM, as well as we can do the Bayesian classifier to do the segmentation and classification of speeches and music, etc. Issues. These are the model-based methods. These are having a problem to work out in a real time, as well as it needs lot of iterations and lot of training of data. Next, audio clustering. We can cluster the speech based on the gender or speech segment of same speaker. These is an approach or applications and issues. Large clusters sometimes may give the biased result. Next we will go for the text mining. First task is pre-processing. We can apply the approach as we can do the part of speech tagging, stemming, stop word removal, as well as we can do text chunking, etc. The issues are ambiguity is the main problem, and single word different meaning in different contexts. It's another issue. Next task is picture extraction and transformation. We can identify an important keyword using TF and IDF, etc. issues. Different size and context of the document is an issue. Next one is text classification. We can use the approach K nearest neighbor classification, decision tree classification, Navy Bayesian classifier approach we can apply for the text classification. The issues are the final decision depends on the few terms relatively. Next task is we can do the clustering of the text by using the bisection, K-means clustering, or by using the co-clustering methods. issues. Finding the good distance in the cluster is a big issue. These are the trends in audio and text mining. We can do it the monolingual or multilingual. We can do the static correlation or dynamic correlation based on the content. Next, web mining. We can use data mining techniques to uncover hidden patterns, or we can find out the relationship among available data. The web mining taxonomy consists of web content mining, web structure mining, and web usage mining. These are the challenges of web mining. Finding the relevant information. Second one is understanding the customer need as well as the need of the individual user. Third, lagging of efficient frequent pattern mining techniques. And the fourth one is weblog analysis of the entire database result. It takes a lot of time. It's a time-consuming process. The last one is struggling to attract new customers and retain the regular users. These are all the challenges of web mining. The objective of the web mining is we can analyze the weblog file, we can build personalized recommendation model, we can provide efficient web page re-ranking method, we can identify the interested user through the decision rule, we can identify the popular pages in a website by analyzing the number of user access the web content and finding the patterns. And also we can apply the fuzzy temporal association rule mining to find out the relationship in the web content, as well as we can find out the association rule by using the improved a priori algorithm. This is the taxonomy of web mining. The web mining is divided into three components: web structure mining, web usage mining, web content mining. In web structure mining, we can mine the XML schema, or we can mine the HTML documents, or we can do the navigation. The web usage mining, we can do the personalization, business intelligence, customer profile, we can use our own profile, we can do the system improvement, we can find out the recommendation model, e-commerce, introduction, deduction, web agents. And in the web content mining, we can do the clustering, association rule mining, semantic web, web page content mining, we can search the result from the mining, we can use the text mining as well as the image mining. On the whole, we can retrieve the information by using the querying, indexing, as well as by using the evaluation method. Thank you.